find the derivative of these functions, and we're going to use it using the previous rules from before. So everything is still applying. So if you look at the first one, what do you notice about this one? Pardon? It's multiplying. We are multiplying x squared by e to the x. So what rule do we have to follow? Product rule. So let's do it. So what is your first function and your second function? Okay, and then you go through the same process. So you find f prime and g prime. Good. And then you just plug it into your product rule, which is f prime times g plus g prime times f. What else can you do once we have this derivative for what with our y prime? Okay, we could, you mean set it equal to 0 and take it over? Okay, so organize it, meaning write the x squared first. Yeah, we could do that. What else could we do? We could take out what's common. So let's just say to start, we took out e to the x. Is there anything else we can take out? Yeah, we can take out an x. So I'm going to keep this separate, and you'll see why later. But this factors into these three factors. So if we apply the chain rule, we have outside function is e to the x, inside function 3x plus 2, and then find your derivatives. So with those derivatives, you follow your chain rule, which is y prime equal f prime e to the x, but you have to keep g inside, which is 3x plus 2. Then you have to multiply by g prime, which I'm just going to put in front, and that's your derivative. With it being a product rule, you still say your first function, your second function. What's your first function here? 2, good, e to the x. Your second function is cos x, and just find your derivatives as usual. So now let's substitute them in. So we have f prime of x is f prime, which is 2 e to the x times the g cos x plus g prime. Our g has a minus, so I'm going to put minus sine x times f. I'm going to put the 2 in front and then e to the x. The order of that, though, doesn't matter. So now we're going to have to find the local max and the min, which is all the same as before from our curve sketching. All right, so with the previous derivative, which was e to the x, x, 2 plus x. This was after we had completed the factoring. So it was one polynomial that had 2 terms. And then after we factored, this is what we got. So if we're looking for local extrema, or max or min, how do we find those? What do we have to set? Yeah, we set this equal to 0, and this will find what? Critical numbers, and then we'll have to find the critical points. But how do we know if they're local max or local min? Second derivative test or the first derivative chart. It will also tell us from the increasing, decreasing. Okay, so if we set this equal to 0, you don't have to have these brackets around, but I put them to show that there's a variable there, so each bracket has to get set equal to 0. If we put like a number 3 in here, that 3 does not have a variable. We do not set that equal to 0. Only the parts that have the variable. So that's not there. So let's set each part equal to 0. So we have e to the x equals 0, x equals 0, 2 plus x equals 0. So this one's done. X to the 0, we're good there. This one we can solve. X equals negative 2. So we have those two. Now we just have to solve this one. So the other alternative to solving this is to look at your log properties. So if we wanted to solve for x here, you could take the log of both sides, right? We could take the log of this and the log of this. Now, log doesn't necessarily help us here because we are e. What's the inverse of e? Ln. Lns behave in the same way as logs do. So when you take the ln of e to the x, the ln will still bring that exponent down. Why would we pick ln here instead of log? So once you've solved and you have x equals ln 0, if you remember the ln graph, a ln graph will never touch when the x value is 0. So see ln of 0? You will not reach there. So this one does not exist. So with these values here, you're going to either set up, your options are your first derivative chart or your second derivative test. And each of these will tell you then whether there's a max or a min. So go ahead and try that. So if this was our chart that we came up with from doing our test values, subbing into f prime, if we went from increasing to decreasing, we are at a maximum. At what point? Or at what x value? -2. We went from decreasing to increasing. We're at a minimum here. Okay? So that's your alternative then. Subbing in -2 into your f double prime and subbing in your 0 into f double prime, and you would get negative and positive. Therefore, you have a max at -2 and a min at 0. How do you find the whole point? So if you sub them back in, so therefore there is a max at -2. I think it's 4 over e to the 2 and 0, 0 by subbing back into your f.